some other diagrams that we've already seen. So title page, everybody should have gotten the title page. You know your name, and if you know your name and you put it there and you gave this thing a title, then you got the 1 point. And if you have a check on something, that means you got full points for whatever it was. This next part, some people did a really good job. Some of them were messy. That was okay. Some people just had a picture like this with nothing labeled. So, and some people had a picture like this and then a list on the next page. But the best way to do this, a few people figured out, is to just put letters by these things. Like next to this thing, you could put an A, and then you could put an A next to the power piston crank on your list. So just a bunch of letters on the picture, and then over to the side, a list with the letters. Whoops, sorry, my ukulele down there. Brief summary. How does the engine work? I gave a lot of 1.5s on there because some people didn't say much and some people said wrong things. So I'm going to give you, I'll try to sum it up. Brief summary. This Stirling engine works by causing air in the cylinder to be heated and cooled, and heated and cooled, and that heating and cooling causes expansion of the air, pushing the piston up, and the cooling causes shrinking of the air, pulling the piston down. So let me see if I can make that even more concise. This Stirling engine works by heating and cooling the air. When the air is heated, it expands and pushes the power piston up, and when it cools, it shrinks and pulls the power piston down, and that makes everything else move. That's really the essence of what's going on. And there were some people who clearly, you just kind of looked up, how does a Stirling engine work, and you copied and pasted. And I want it to be in your own words. You could say what I said, but make sure it's in your own words. This 6 points for a video. Some of your videos, you didn't give me access. It looked like your video was fine. I think most people got the points for this video, even if I didn't have access at the time. So that wasn't a big problem. A lot of points were lost on number 5 and number 6, and I'm going to explain those. Those were just like these old Stirling engine questions. So number 5 is asking about the displacer crank at the top position. So that's what this picture shows. So I'm just going to go through and explain what's happening, and then I'll look back and I'll see whether I hit all these 6 things I was supposed to do. So when this lifts up like this, that pulls the string up, and the string is attached to the displacer, and the displacer goes to the top of the container like this. Some of you said that this displacer, I'm going to label it displacer, steel wool. Some of you said the displacer is what pushes the rod up. That's not true. The displacer shouldn't actually push the membrane up. The displacer just moves up. And the important thing that it does is it causes the air to be displaced downward. So when the displacer goes up, the air goes down. And when the air goes down, the air is by the flame. And when the air is by the flame, the air heats up. And when the air heats up, its volume grows. There are different ways to explain why the volume grows. You could say when the air heats up, because of the flame, the particles move faster, they create more pressure, they push outward, and it expands. But in the end, what happens is this hot air expands, increases the pressure in the whole container, and that pressure pushes the membrane up, which pushes the displacer, or sorry, the piston, the power piston up. So let me go back and make sure I got the bullets down. Where's the displacer? It's in the top when the crank is up, because the crank is what pulls the displacer up. Where's most of the air in the cylinder? It's at the bottom. Does the power piston get pushed up or down? It gets pushed up. When the air is down here, that pushes the power piston up. explain why the power piston gets pushed up or down, talk about these three things. So this power piston gets pushed up because the air molecules are speeding up, because the air is heated up because it's next to the flame. The air pressure increases because the molecules are moving faster, and that increasing pressure is what makes this bulge out and push this rod up. And the air volume gets bigger. So these three things are kind of saying the same thing over and over again. You heat this air up, it moves faster, the particles do. They spread out, increasing the volume, increasing the pressure, and both the increase in volume and pressure, that's what pushes the membrane up. You can see it bubble up because the air is growing inside and the pressure is increasing. So that's number 5. I think I've said everything twice at least. Number 6 is like this picture. The only thing that's different here is that the crank is down, which means this rod is down, which means this string is down, which means the displacer is down here. So now the steel wool is there. So there's the displacer and the steel wool. The displacer is made of steel wool. So if the displacer goes to the bottom, what does the air do? To the top. So the air is here. And if the air is up there next to the ice water, then the air cools down. And when it cools down, the molecules move slower, they have less pressure, and the volume shrinks. So somebody tell me, what does that do to the membrane? Does it puff it out or suck it in? If the air cools down, the molecules slow down, they push less hard so there's less pressure, the volume shrinks. What does that do to the membrane? Just blurt it. Sucks it in. So the membrane does this. The membrane gets sort of pulled in by this shrinking air, and it's really not as simple as that, but you could think of it that way. The air shrinks, there's less pressure, this gets, quote, sucked down, and that pulls the piston down. So this is earlier when I was giving my brief summary of how it works. Here the air is cooling off and pulling the piston down. Here the air is heating up and pushing the piston up. And what makes it heat up and cool down is the displacer making the air go to the hot place, or the displacer making the air go to the cold place. So now let me just hit these things down here. So in part 2, where's the displacer? It's down at the bottom. Where's most of the air in the cylinder? It's up at the top. Does the power piston get pushed up or down? Down. This thing gets pulled down by the sucking in of the membrane there. I need to say something about why the membrane does that, or the piston moves down in terms of molecule speed and pressure and volume. So I've already said it, but here it is again. The air is getting cold, so the molecules slow down. So instead of spreading out, they take up less space, they have less pressure, and that causes the air to shrink and pull the membrane down. So instead of more pressure pushing the membrane out, we have less pressure allowing the membrane to get pushed in. So in reality, it's the outside air now being stronger than the pressure of the inside air because this pressure is weak. But you could just say there's less pressure, the air shrinks, and that's because the molecules slow down, and that's what pulls the membrane down and pulls the displacer down. And that's the biggest chunk of points on this whole thing, those two parts. Then the next part, the flywheel. This I was hoping you would do a little bit of research on, and some people did a little bit. There were only a few people I gave full credit. So here's why you need a flywheel. The flywheel, you can't see it from this angle, but it turns around and around. It's rotating like this. So how many times during one crank rotation does this power piston get pushed or pulled? How many times? As you rotate the flywheel around, how many times does this membrane push or pull? Twice. It pushes once when this crank is at the top, and it pulls once when the crank is at the bottom. But what about the times in between when it's not pushing or pulling? What makes the thing keep going then? Why doesn't it just stop? It's because of the momentum of the flywheel. So here's the answer to why you need a flywheel. This flywheel has momentum that keeps it moving around in a circle. We've talked about linear momentum, where an object in a straight line, its momentum tries to keep it going in a straight line, but things that are spinning have angular momentum. You don't have to use the term, you could just say momentum. So when this pushes up and then doesn't do anything for a while, and then pulls down and doesn't do anything for a while, when it's not doing anything, the flywheel keeps this crank turning. So the answer is the flywheel has momentum to keep turning the crank even when the power piston's not pushing or pulling. If you didn't have that flywheel there, you'd just get a push and a pull, and this thing wouldn't even go all the way around. It would just go a little bit, and it would stop. The flywheel keeps it moving because it has momentum. If you have questions, just jump in and interject to those questions. So then the what went wrong, this is totally up to you. I'm not going to give you the answers to this. I just want you to say what you think went wrong and how you could fix it. Make sure you do both of those things. And then explain. Now, for some of you it didn't really apply, but explain how that would make the power piston push harder. Because for most people, the problem is that the power piston isn't pushing hard enough. Some people have another problem, and if you have another problem like friction, then explain how your fix would result in less friction. Oh, and then this last one. This is the one that people understood the least, and I wish I had a Stirling engine I could do this with. So, but I don't. So you're just going to have to imagine this. In fact, I'm going to go to my website because I've got a better picture of it here. Oh, that's physics, sorry. Okay, so here's, you know what I can do? Do this. I'm going to freeze my screen, and I'm going to turn this on. Point this at the screen. This is for people who are watching this video later on. All right. I think this will be good. Then I can stand here and explain. Okay, so here's what this question's asking. You get rid of the flame. There is no flame. And you get rid of the ice. There is no ice. I'm going to have an easier time getting rid of the flame than getting rid of the ice. So, no flame. Trying to get rid of it. And there's no heat source. There's no cooling. All there is this. And you grab the flywheel and you start spinning it. You make it go around and around and around. What does the displacer do? You could imagine this, right? What would it do if I started spinning the flywheel? Would it sit still? No, the crank would make it go up and down. And what would the power piston crank do? It would go up and down too. And this is the important one. This is the important one right here. So I'm spinning this around, and when this goes down, it's going to push down, and the membrane's going to go in like this. And when it does this, is it stretching out this air, or is it squeezing this air? What's it doing when it pushes down and it squishes the membrane in? Squeezing or releasing? It's squeezing. And when you squeeze air, when you compress it, what does that do to the temperature? You make it hot. So in this position, this would be hot. And if you kept rotating this, then at some point, the power piston would go up, and that would make the top do that. So is that squeezing the air now, or just the opposite? This is the opposite. This is stretching the air. So what do you think that does to the temperature? Makes it cold. So as you hold this thing over here and you spin, 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 this goes up and down and up and down and up and down. When it stretches up, this gets cold inside. When it pushes down like this, and it squeezes the air inside the cylinder, then it gets hot. So it's going to go up and down and up and down, hot, cold, hot, cold as it goes in and out. So that's showing how this could be used not as a machine that's driven by heat and cold, but a machine that actually makes heat and cold. If you started out and the whole thing was room temperature, whenever this pushed down, this would go a little hotter than room temperature. And whenever this pulls up, this would actually get a little colder than room temperature. So that's what I'm getting at there. And just to be really clear, let me go back to this and try to fix my camera now. Okay, so number 9, hardly, like I said, hardly anybody got credit for this one. Without using a heat source, show or explain how you can turn the flywheel with your hand, causing the air in the cylinder to be heated and cooled by the power piston rod. Describe when the cylinder is being heated. That is when the power piston pushes down, compressing it. That's this. And why is it being heated? Because the power piston is squeezing the air in the cylinder. And then when is it being cooled? It's because it's when the power piston is pulling up like this. And I guess the best explanation for that is the air is being cooled because it's expanding. Here it's being compressed, here it's expanding. If you let the air expand, you cool it off. If you compress it, you heat it up. The bonuses, I'm not going to spend any time going over because those are just bonuses.